Hi there, Toby here. Um, I'm continuing my work on implementing closures in the Play language. So last time was a very exciting time. Um, I I did a little bit of coding on Saturday, and I was able to get the code generator. This piece of code. Let's see. Hello. Oh, not this one. Generator. This piece of code to make use of the heap when it needs to, for the case where it's writing variables into a closure as opposed to a stack, which is what it normally does. Let me put on my glasses so I can see. This time, let me show you the end result of that. So then now we have this app with which you can click on the button and it'll update this label. And let me look at that program here. I believe the program I'm running is the closure example number 4, so that's this one. I had 2 inner functions that is making use of closures. I'm gonna get rid of the second one because that one doesn't really do anything meaningful. And let's go ahead. Let me recompile this program. And so that there's less superfluous stuff going on there. So now, if you click on this button, we can actually do interactive things with the program, such as click on a button and have it update a label on the screen, which is what these lines do. There's a counter variable which is stored in the outer scope. Thus, we're using closures. However, the thing I want to fix this time is that when we're inside of a function, whether it's the inner function, as is the case here, or we're inside of the main function, we no longer see the counter variable in the stack frame because we put it in a closure. It's not in the stack. The debugger code currently displays the variables that are in the stack, and we need to extend it to be able to display the variables that are in the closures as well. We built in a way to do that. And if you're not familiar with how this works, how the back-in-time debugger works, I'll explain as we go. Basically, we actually don't have a history file. As the program executes, there's a history array, which gets new entries get added to the history array as new lines of execution happen in the program. So, for example, this history array is 57 because 57 lines of program have executed thus far. If we click the button, then we'll get more lines in the history. I guess I need to go back to the place where there is a button. Also, the suspension of the debugger is a problem that I would like to address at some point, which is not. So that I would like to make it so that when the debugger is in effect, then the regular program cannot be interacted with, because if you were interacting with the program while the debugger is frozen in a previous state, then you sort of have this fork situation, which I don't really want to get into. I wouldn't know how to handle that case. Excuse me, let me get my stylus hooked up so I can draw stuff on the screen. Okay, yeah, so what I was trying to say is that, hello? Oh, there we go. What I was trying to say is this grub bar is really a timeline. So if we went back in time, like let's say here, does that even work? If we went back in time, somewhere at this point in time, and then we click the button, well, what should happen? Well, in reality, or not in reality, but logically, what should happen is that should have forked the timeline, and we have a fork like this. And I guess that is a possibility. I just don't have any code to handle that case. So what happens instead is new history items actually get appended to the end of the timeline, but those are incorrect now because those additional code didn't happen after the end of the timeline. They happen starting from that point in time, and then that just doesn't make any sense. So suspension of the running code while we're in debugger mode is something that I want to put into my to-do list. Let me just go ahead and do that. I'll say suspend execution while in debugger mode. That's another thing I'm gonna need to do. We did get done these two things, at least the first cut of those two things last time, which is great. Anonymous functions. Oh, we know we have a problem with anonymous functions. I'm not sure what to do with that yet, as in I'm pretty sure if I made this function anonymous, for example, then we'll have problem getting closure to work. Yeah. I wonder if I can test that. Let me try. So if this was an anonymous function, but then I cannot assign this to a variable. Oh, maybe I can. Initialize UI equals that, like that. Does that even compile? It compiles, but there's a problem in the closure code. Okay, that makes sense. Let me go to the closure code. But I don't know that it's in the traverser actually. I don't know if I want to fix that problem this time though. Let me see. And then it goes to the closure code, which is in here. Hello, and then it's line 31. Because there's no name, the function's got no name. So I don't really know how to handle this case. I could generate numeric IDs for the anonymous functions. But I'm not, I would rather do something else right now. Okay, so this should work again. Okay, what I want to do right now is to display the variables in the stack frame within the debugger. And let's go into the debugger code, which is somewhere inside of the runtime. That's just how it is currently. Later on, I might move this out and perhaps put it into a Chrome DevTool panel. Okay, so this is the time traveling debugger UI. I coded it using the native DOM API using document.create element, etc. So in a very low level way, instead of using a framework like React or Angular. Usually when I'm making personal projects, I tend to prefer to stay nimble. Well, it depends actually. It depends on the situation. But in this case, I really wanted to keep this runtime small. So I didn't want to add a framework into it. Okay, so I'm looking for the place where I'm rendering the stack. I think it's, yeah, there it is. This is the sync stack frame display, which is in charge of rendering the middle panel, which is the stack frame. And previously, well, currently I should say, it would loop through the stack, which is an array of frame objects, and for each frame object I would generate a UL list, looks like, with some LIs inside of the UL list. Each entry would sort of be this variable name equals this value pattern. Now what I need to do is also display its closures, which let me split this file to the right so we can see side by side, because I want to show you the push frame function. The push frame function also put a thing called closures onto each frame object. So a frame object actually also has closures in it. And let's do this. Let's, for now, just for now, for each closures, if the frame has closures, I'm gonna loop through each closure. I know closures is an array, so I'm gonna use for of instead of for in to loop through it, and then I'll push another li element. Apparently I want to style these as no bullet points. I will follow that convention, and then here I will just put, for now, the ID of the closure. Alright, I think I have to recompile the program. Now I messed up. I actually need a closing parenthesis there. Okay, so let's see that work. I'm gonna go back to the, so number 5 is a closure, and number 6 is the closure of the nested function called initialize UI. So that much is working, but that's not all, because for each closure we actually need to look up the heap to get at the closure object. So I need to call the heap access function, which is a function I made for myself for the purpose of giving an ID. Oh yeah, let me just explain one more time, in case you're not familiar with how my heap architecture works. Okay, so I'm gonna go to like Python tutor. Okay, so Python tutor. Okay, so let's say you write a program in Python tutor. I'm gonna do it in Python. Okay, so let's say you have a variable called I. Well, I is less than 10, you're gonna say I equals I plus 1. And you click visualize execution in here. Well, this is the stack frame, these are the frames, and then there's the objects. That's the heap. So and this is the fact that the program has access to two separate areas in memory, one called frames and objects. So both of these are areas in memory. Okay, both of these are areas in memory, and the objects area in memory, that's in computer science. In computer science parlance, that's also called the heap, which is what I'm calling it in the play language. The frames, I call that the stack. You may hear people call this stack frame, same difference. So my parlance is the stack and the heap. The heap is used to store composite data structures like arrays and dictionaries. Okay. I actually and in this case I'm using a dictionary to represent closures. So my closures are actually simply dictionaries that are in the heap. Okay. So let me show you in Python tutor what that looks like. So maybe we have numbers. It's an array. Numbers dot append this I onto it. The moment you create this numbers array, we created a numbers variable, and it's merely a pointer to an empty list at the moment. But the moment we append a number in it, this list has got slots in it. In Python, it's called lists. You can think of it as arrays. The difference is subtle, but you can think of it as the same thing. So in the play language, what I did is instead of this looks like an arrow, and that's great. And I'm hoping to implement a visualization like this at some point. But what I've done is whenever the variable is actually pointing to an array or another composite object, such like a dictionary, in the heap, then in reality this guy is just a number. Let's say the number 1, because each object in my heap has an ID. So let's say this array has ID 1, and then your numbers having the value of 1 will mean that this actually refers to this object, and so forth. So that's how this works. And when we access the heap, we use the heap access. Closure has a number in it right now. So, whoops. The variable closure has a number. It could be 1, 2, 5, 6, or whatever. I'm going to use that number, that ID, to access the heap. And now we actually have a dictionary. So this guy has the variables in it. And then for each variable, we're going to loop through it. The variables is actually a dictionary at this point. Let's just print it out and find out that indeed it's a dictionary. Who knows? I might be wrong about that. Okay. So we do see vars is a dictionary which has a counter variable in it. So that's good. That's what we need. We can loop through that now. Just like these lines, actually. I think I'm just gonna steal those lines. I think, but instead of using it to loop through the frame.variables, I'm gonna use it to loop through the vars that we access from the closure. So let's see if this works. We have counter now, but it says undefined, and I'm not sure why counter would be undefined, because we set it to 1, didn't we? Oh, yeah, well, that's wrong. That should also be changed to access var name. Oops. Vars. It should match this name. Alright, go back to the beginning of time, and we have counter equals 1. Wonderful. Now the key is, in label is 10. Here label is actually an element, and the way the virtual DOM was implemented in Playlang is virtual DOM elements are actually simply represented as nested dictionaries and arrays. So label is a virtual DOM object, so to speak, but it is simply the object in the heap with the ID of 10. So if you look at the object in the heap with ID of 10, that is actually a dictionary with one key value pair. The key is tag and the value is label, and that's it. And also at the moment we haven't even given it any text, so it doesn't have children, and it also doesn't have any attributes because we didn't give it attributes. Okay, let's step, and then now we do the event listener, and then the program is done basically. But we haven't clicked the button yet. We click it and we see a label that shows the counter now, which is 2. Apparently these lines should have happened because otherwise we wouldn't have been able to see this change. But we don't see the step count increasing, but that's because I haven't written the code to have the debugger update itself when in the case of event handlers or code happening as a result of event handlers. The debugger is basically ignorant of event handlers at this point. However, if I went backwards, then it picks it up because I basically, that the clicking of this button triggers the code to update the display of the entire debugger. Let me see what that code does exactly. So it's this one. So if the range changed, then we're gonna call this sync all function, which will, I think it's at the bottom. Sync all. It synchronizes the range value, the state, program state, the stack frame. It synchronizes this entire display in the event that you click a button. So potentially we could just get it to do that as well, but I also kind of don't want to do that because I'm thinking about maybe what is proper is to have a debug button that allows you to turn on and off debug mode. And when you are in debug mode, like we discussed before, we probably want to suspend the actual program when we're in debug mode. But at the moment, that's not done. But anyway, this allows us to step backwards inside this event handler. The reason we see empty set of parentheses right now is because this is an anonymous function, and this doesn't have a function name, and the display of the stack frame is just not handling that case very well. But you do see that we have we're able to see the counter variable value as well as the label value. The counter variable came from the frame, the scope of the main function, and the label variable came from the scope of the initialize UI function. So it's two separate closures, but we can see the values of the variables in here. Okay, I'm very happy with this. I guess I think what I said, the suspension of execution while we're in debug mode, I think is important. And let me think, what else should I be working on? Another thing I want to work on is just maybe build some toy programs using the Play programming language, which they weren't all that interesting. Well, they were somewhat. I made a chessboard and everything. Maybe I can make the chessboard do something more interesting. So make some toy programs. Let me see. Display closure variables. That's the thing I just did. So move it down here. Anonymous functions, we don't support that at the moment. Things would break if we tried. I already tested that. Debugger, I said maybe don't show the virtual DOM. So all of these elements, all of these things, it's kind of crowded right now. All of these things are the virtual DOM, are elements of the virtual DOM. Anything that's got tag, this is the virtual body tag, this is the virtual script tag, which mirrors the actual DOM, which is here. So this guy, and we got, where's the script tag? I actually don't see the script tag for some reason. Oh no, there's the script tag. And then we have a DOM. Oh, I appended the debugger UI outside of the body so that it wouldn't affect the actual program. When the actual program tries to deal with the virtual DOM, that was a trick, I see. So that is the debugger UI here, but the actual program, in the view of the actual program, the state of the DOM is what is inside of the body element, basically, which is, so it has to have a virtual representation, virtual counterpart for each of these elements. And that's what these is. There's a virtual body, there's a virtual script tag, there's a virtual button as well. The virtual button has children, which only has one element, number 8. And then number 8 is simply the text of click, which is the thing inside the button. Also have a label, but the label doesn't have any children at the moment until we step and step again. And now the label has stuff in it. And then at this point in time, so I can step backwards and then forward. So, and at this point in time, the label's children is 10. Label is 10. And then that is, we actually, let's see. Label is 10. Yeah, label is still 10. Okay. But it's just that the thing inside, the thing under ID 10 has updated once we did this set text line. We set the text of the label to this string here. What is in 10 has changed. It used to be just a label element with no children, but now it has children. And where is its children? It's under ID 12. And it's simply text that says current count is 2, which is why you see that here on the screen. Okay. What was I trying to say with explaining all of that? Oh, I guess what I was trying to say is I feel a little bit like this is too crowded when all of this virtual DOM logic is sort of occupying a lot of the heap area, and a programmer who doesn't really know how the virtual DOM is working, they may get a little confused by seeing all of this output. I'm not sure how I feel about this. I have also considered not having a virtual DOM at all, but let me just think about that. Okay, anyway, so I'm gonna do a commit right now. I'll say added closure variable display to debugger. well, let me double check my debugger, not my debugger code. All I did was this. One possibility is we add additional styling to show the fact, or to indicate to the user that these variables are coming from a closure instead of a frame. Let me think about that. I'm not sure what is a good way to visually indicate that, and I'm debating between a couple of ideas. Okay, so I just pushed it, or did I? No, I didn't. Let me push my code. Okay, and now I'm going to try to make a slightly more interesting program, perhaps, and perhaps also use this as a demonstration of the programming language. So I want to make a to-do list. All right, so did I already have? Oh yeah, I already had a to-do list program, kind of. So it creates an array containing two to-dos in it. In this language, at least the current state of things, as it always might be changing, in order to deal with the DOM, you have to call get document body first, and then you would append elements to the body. So here we create a input field, a UL list. You can set styles using the set style function, and then this is appending both of those things to the body. And then here, for each to-do in the to-dos list, I'm creating an li element and then appending it to the list. And then here, the event handler is where I got stuck last time, where it's trying to append new to-dos to the array, but that's not gonna work. But now it might actually work. So let me try that. I'm gonna compile the to-do program. Oh gosh, there's something my traverser doesn't even handle yet. Whew. Which is a list literal. All right. Example-driven programming. I don't write tests. I guess that's a downfall of not writing tests, but I kind of like doing it this way for personal projects, where it's well, there's trade-offs. I like writing tests as well, but currently I have not yet done that. Okay, so this is the traverser, and with the list literal, if we look at the AST of, so the traverser, this traverser is something I did last Friday, extracting out a generic traverse function to traverse the AST, which has all the intelligence about for a given a node of a given type, where its child's nodes are, and therefore it knows to go into its child nodes and recursively call itself. Just to be sure, I'm gonna look at what a list literal looks like based on the AST file of this to-do program I have. Okay, so this tells me a list literal node has a property called items, which is the array we need to be going into. So I'll say for let item of node dot items, I'm gonna need to traverse you while passing in the same visit function. Okay, I think that's probably it. Oh, we have an undefined reference. The variable reference detector already has caught some things. Let's see. So line 15, column 22, line 15, column 22. Oh, it's that the loop variable. That's another thing that I was gonna put on my to-do list. Let me go put that on my to-do list. So for is it? I think this is the closure gather closure info function. Doesn't work with the loop counter variable or loop iterator variable of a for loop, because the for loop is a special case where the statement itself declares a variable, but we didn't account for that case when we were going through the AST looking for definitions of variable just based on variable assignments like this. So we actually need to go back and fix that case. We need to actually say to do is actually a variable that was declared in this scope because this for loop declares it. And I believe that is in the closure. Yes, we did this also last Friday. And we need to be able to say, basically for this case, we need to say the to do is a, let me see. To do is declared in this scope. Although I don't think it contributes to a closure because this inner function is not making referencing to do in here, right? But I do need to in the function there. I know there's an inner function that's going in and finding variable assignments, like here. We need to take the for loop into account. So else if node type is for loop. Alright, let me look at what a for loop node looks like here. Oops. Okay. For loop has a loop variable which is an identifier. So if there's a for loop, I actually want to take its loop variable, which is an identifier, and put it in there. Wait. However, that's gonna cause a problem because this function is returning things of type var assignment, but the loop variable is not a var assignment, it's an identifier. That's gonna cause trouble. I think it will. Yeah, I think that's the sign of it causing trouble. So I think what I may need to do, let me see where this is called. These are the variable assignments. Let me see how they're used. Perhaps we can reduce it down to just the identifier. Oh yeah. Okay, I'm gonna do that. So no wait. No, yeah. Okay. This is what I'm gonna do. I'm gonna push the note that alright. I'm gonna need to look at what a var assignment looks like. It's var name, isn't it? Var assignment. Var assignment has a var name. I'm just gonna push the var name onto the results. And at that point, both the type of both the var name of a var assignment and the loop variable of a for loop are identical because both of them are identifier nodes. Okay, so now we go back to here. Now we assume this is an array of identifier nodes, and we no longer have to use this map to convert this guy to identifier nodes by looking up this var name property. So we get to get rid of this guy if we made this change. Let's see if that works. Okay, it appears to work. And I want my test file to reference the to-do program now. Let's see if that does that. Okay. All right. So we can go back in time and rebuild this to-do list. That's number one. Number two is we should be able to type into, so finish the debugger. If I hit enter, well, it hasn't done anything to the DOM, but I believe, yeah, we actually get to iterate through, or not iterate, well, walk through the steps that happened due to the key press. Oh, actually multiple key presses happened, but only one of them happened that triggered, which satisfied this conditional, which allowed it to enter this chunk of the if statement. So what we could do now is append another, in addition to adding a item to this to-do list. This is how you push an item onto an array with the push function. Let's also add another new li. Ooh, this is confusing. I'm gonna call this li. And then here I'm gonna call, I'm gonna rename this task name, to do name, maybe. Task name is good, probably. Alright, I'm gonna call it task name, or maybe new to do. I'll call it new to do, because here I've been calling it to do. Alright, so the new to do, I'm gonna make another li. Now this is actually in the way I've designed this programming language, because this variable name is the same as the one out here. It actually referenced the one that's out here, which is different from how JavaScript behaves. Okay, so that would actually create a closure. I'm not sure I like that, but okay. Alright, anyway, so now I'm gonna say text li new to do, and then append that li to the list. Alright, let's see if that works. Compile the program again, run that. So now I can say something like finish the debugger, enter. Dang it, did that not work? Oh, it's a pen 2. Did I get an error because I misspelled the name of the function? I did. Okay. Okay. Another thing I've been thinking about is use static analysis to check for reference of undefined functions as well, and then we will have been able to avoid that problem. Although then there's the parameter list verification, which that's going to be harder. Okay, so anyway, I'm going to fix the problem. That should be called append to instead of just append. Compile. Finish debugger. Enter. Oh yeah. Yes. That's amazing. Yeah, so we have a to-do list. Maybe That should also clear the text box. So let's go ahead and clear the text box. How do you clear the text box? Well, it's called field. I'll just set text field empty string, and then it should be able to clear the text box. Finish to-do list program. Enter. Wait, that didn't seem to happen. Oh, it's an input. It needs to be set value because inputs don't have text. Inputs have value. Okay, let me see what we can do about that. Does it get value? I think. Yeah. Also need a set value. Input ID. So I guess at some point in time I made a virtual DOM to native DOM map. So if you want to get direct access to the native DOM, you have to look up this map. And then now, well, we have input, which actually is a real DOM element, and we can set the value to the value that you desire. So with this addition, we should be able to say set value, set the value of this field to the empty string. Try that one more time. Yes! Amazing. We can make a to-do list app. Okay, I'm gonna take a break. This is enough accomplishment to be enjoyed for now. And in the future, we'll continue working on this. Work down some of the items I wrote down in my to-do list, and see where we go from there. Another thing I might want to do too that I just thought of is just do some code challenges. Do some code challenges such as on Code Wars, etc. Okay, all right. I'm gonna stop the stream here, and thank you for watching.